we are going to state the statement of the Bernoulli's theorem. For the streamlined flow of an ideal liquid, the total energy per unit volume remains constant. So first of all, we are going to define that what's the meaning of an ideal liquid. Ideal liquid. Now whenever we are using the word ideal liquid, it is one which is perfectly incompressible. So first thing is that it must be incompressible. So it must be perfectly incompressible. And second thing, important thing is it should be non-viscous. So it should be non-viscous. So ideal liquid means which is perfectly incompressible and non-viscous. Second statement, we are saying total energy remains constant. So here, what's the meaning of the total energy now? So in case of liquids, when we are using the word total energy, basically total energy constitutes of kinetic energy, potential energy, and third one is termed as pressure energy. Now the sum of all these three energies, if we are going to add all these energies, so sum of all these should be constant. So that is the meaning of the Bernoulli's theorem, that for an ideal liquid which is completely incompressible and non-viscous, the sum of the kinetic energy, potential energy, and the pressure energy remains constant. This is as per the statement of the Bernoulli's theorem. Now here we are going to prove the Bernoulli's theorem. Now in order to prove the Bernoulli's theorem, we will consider a case in which the liquid is going to flow from this cross section area to this cross section area. So this is the shape of some container and the liquid is going to flow from here. So when we are saying it's a container, it means liquid will be going to flow from this end to this end like this. So there is a flow of the liquid like this. Now we can consider that, let here the cross section area of this is A1. I am naming this end as A. Velocity by which it is going to emerge out is V1, and let from the ground level this height from the center, I am taking it as H1. Height from here, I am taking it as H2. Pressure at this end, I am taking it as P1. At this end, I am taking the pressure P2. Velocity, I am taking it as V2. Area of cross section of this, I am taking it as A2. So these are some of the basic facts which I have taken. Now since the water is going to flow from the lower level to the higher level, so pressure at this point has to be more than this. It means P1 will be greater than P2. Now when the water is going to flow from the lower level to the higher level, then some sort of work has to be done. So first of all, we are going to relate the expression for the work done. Now as we know that the amount of water entering from here will leave to this end, it means according to the principle of continuity, A1 V1 will be equal to A2 V2, and this is equal to the amount of the water flowing, or you can say this is the volume, right? Now if we are going to multiply this by the density on either side, so this become volume into density. So volume into density will become the mass. It means same amount of mass is going to enter from one side and the same amount of mass is going to exit from the other side. So we are writing A1 V1 into rho is equal to A2 V2 into rho, right? But basically it means the volume per second always remains constant, right? Now what we will do, we will find the expression for the force at the end A. So since we know this formula, pressure is equal to force upon area, so we can write force is equal to pressure into area. So if I am going to apply it for end A, so at A position if I'm going to write it as. So I'm marking it as F1. So F1 will be pressure P1 into area A1. Right? Now we want to find out the expression for the work done. Work done is equal to force into displacement. So what I can write, W1 is equal to F1 means P1 into A1 into displacement is your x1, but for 1 second velocity and distance are same, so I can write it as V1. So ultimately my statement will is P1 A1 into V1. Now my W1 expression for W1, we are getting it as P1 A1 into V1, but you know A1 V1 is the volume, so it means from here you can write W is equal to P1 into V. So this is the expression for the W1. In the same way I can write the amount of water which is going to exit from there will be equal to P2 into A2 into V2, and A2 into V2 is equal to the work done. So W2 is equal to P2 into V. But as we have already done, some amount of work has to be done, so W1 is greater than W2. So amount of work done, that will be equal to W1 minus W2. So from here what you will find that this amount of work done, delta W, will now be equal to P1V minus P2V. Clear? Till here any doubt? No, I think it's very clear. After this, according to the concept of work energy theorem, what we are using now? Work energy theorem. Work energy theorem. So what the work energy theorem says, that the amount of work done, delta W, is equal to change in kinetic energy plus change in potential energy. So amount of work done, already we have calculated P1V minus P2V. Change in kinetic energy, that will equal to half mv2 square minus half mv1 square. This is the change in kinetic energy. What is the change in potential energy? mgh2 minus mgh1. Clear? So from here we can write the expression somewhat like this now. P1V minus P2V is equal to half m V2 square minus half m V1 square plus mgh2 minus mgh1. Now what I will do, I will take all the 1 on one side, all the 2 on the other side. So what I will get now from here, then I will get P1V plus half mv1 square plus mgh1 is equal to, now all the 2 I will take on that side, it will become P2V plus half mv2 square plus mgh2. Now after this what we'll do, since this all ones is equal to all 2, so we can say that PV plus half mv square plus mgh is equal to constant. Now if you divide this by the mass, so this expression will become P plus half my mass by volume, you can write it as density, half rho v square plus rho gh is equal to constant. Now here P is termed as pressure energy, so this is our pressure energy. This half rho v square is termed as kinetic energy, and rho gh is termed as potential energy. The sum of pressure energy plus kinetic energy and potential energy remains constant, and this is the proof of the Bernoulli's theorem. Thank you.